Okay, we are going to start chapter 6 with the first section, which is going to be the basics about rational exponents and function. So rational root word ratio. So we're mostly talking about exponents that are going to be fractions or just like non-whole numbers, and including some negative ones. Okay, you have two learning targets that you can evaluate and simplify expressions with rational exponents, and then furthermore that you can solve equations using nth roots. We'll talk about all that as we go. So the one thing that we need to talk about when we're dealing with real numbers that have nth root of a, you're going to get a different amount of solutions or different amount of answers. And so essentially, if you're taking the nth root of and n is an even number, so like you're taking the square root, the fourth root, the sixth root, if that value is less than 0, you're not going to have any real roots. Really what that means is you're going to have more or less like complex. You're going to have complex solutions, okay? So you're going to see like I, for example. Okay, when a is 0, you're going to have exactly one nth root, and it's going to be 0. Okay, and then when you have your a value is positive here, you're going to end up having two real nth roots. Okay, and that's when it's in integer, or is even, when your n is even. But when your n is odd, okay, so that means you're going to have, when your n value is odd, okay, and your a value is less than 0, meaning it's negative, you're going to have one real root. Okay, and when your a value is 0, okay, you're going to have one real root again, and it's 0. And when a is greater than 0, meaning it's positive, you're going to have one real root again. Okay, so we're going to hopefully see that here in the first couple examples. So let's go ahead and find the indicated nth roots of a. Okay, so if I want to find the nth root of a, okay, it can kind of just follow this general formula, okay, and that is the nth root of a. Okay, this is kind of what we're following, and it turns out that that is equivalent to a raised to the 1 divided by whatever that n value is, power. Okay, so this is basically what we're going to go off of. Okay, so if I'm looking at this, I know my n value is 3. And my a value is negative 216. Okay, so this is just kind of the setup to the problem. This is also equivalent to negative 216 raised to the 1/3 power. Okay, so what does this mean? Okay, so these are equivalent to each other. This means, what's the cube root of negative 216? What number multiplied by itself 3 times is going to give you negative 216? Okay, so you can go ahead and type this into your calculator. I have no problem doing that. Okay, when you're taking a negative number to an exponent or to its root, okay, you need to go ahead and put parentheses around that. Otherwise, you're going to get different values. Okay, let me specify. You're going to get different incorrect values on occasion. Okay, and then we're going to raise that too. So we've dealt with this button before. It's this caret symbol here. Okay, and it is going to be raised to the 1/3 power. So we're going to put 1/3 in parentheses as well. Okay, and we get an answer of negative 6. Okay, so this is equal to negative 6. Why? Because if I take negative 6 times negative 6 times negative 6, altogether I'm going to get negative 216. Okay, and so that's all this is really talking about. And so if we looked up here, we see our n value is odd because it was 3, and our a value was negative. That means we're going to get exactly one real root, and it's going to be, and it is going to be, negative. Okay, let's look at 2. Here, I'm taking the 4th root of 81, which is equivalent to 81 to the 1/4 power. Okay, and if I want to figure out what this is, I can go ahead and take 81 to the 1/4 power, which is just 3. Now, we need to think about this here, because if this is my answer, 3, because that's what the calculator gave me, that means if I take 3 multiplied by itself 4 times, I should get 81. So let's check that. Okay, 3 times 3 times 3 times 3. 4 times, it's 81. That's great. But if we look here in our even category, it says when a is greater than 0, which it is, a is greater than 0, and my n is an even integer, I should get 2 answers. And it says I should be able to get the plus or minus root of this. So I should be getting plus or minus 3. Okay, and this is true. We're going to get 2 real solutions because we just showed 3 times 3 times 3 times 3 is 81. But what about negative 3? Negative 3 times negative 3 times negative 3 times negative 3. Well, that's 81 also. So we're getting 2 answers here. And it's mostly because this number here is even. Okay, so really for the most part, you're not going to have to worry too much about any problem except for when that root is even. So if you're taking the 4th root, the 6th root, the 8th root, the 2nd root, square root, which would be 2nd root, those are when you're going to get multiple answers, okay? And it's always just going to be plus or minus. So you need to be paying attention to specifically when you have an even root, okay? Because you're going to get a positive version of the answer and the negative version of the answer. Where when it's odd, you're only going to get 1 answer, because we can even check here, okay, why it's not plus or minus. Because if I go 6 times 6 times 6 here, that's positive 216, but we wanted to get negative 216. Okay. Why don't you all pause the video, take a moment, and try A and B, and really focus on when are you going to get a 1 solution or 2 solutions, okay? All right, so I'm assuming you paused the video at this point and you're just trying to see how you did on A and B. Okay, so I'm taking the 4th root of 16, which is equivalent to 16 to the 1/4 power. Okay, I'm taking it to an even root. Whenever I'm taking to an even root, I'm going to get 2 answers. So I already know I'm going to get plus or minus. Okay, so for most of you, I'm assuming you're just taking 16 to the 1/4 power, and you're getting 2, so it's plus or minus 2. Okay, and we can go ahead and check this, that 2 times itself 4 times is 16, and negative 2 times itself 4 times is 16 also, so that works out great. Okay, here I'm taking the 3rd root, or cube root, of negative 125, so I'm taking the 3rd root of negative 125, which is equivalent to negative 125 to the 1/3 power. So I'm going to take negative 125 and I'm going to take it to the 1/3 power. And I'm going to get negative 5. Okay. And we can check. We can multiply negative 5 by itself 3 times. Or we can take negative 5 to the 3rd power, you know, and that's 125, or negative 125. As opposed to if I took 5 to the 3rd power, that's positive 125. So that isn't the same. That's why this one is strictly negative 5 and this one is plus or minus 2. Okay, because this one has 2 answers because they both end up working. This one only has 1 answer because only one of them really end up working. Okay, so okay, so we kind of already talked about the roots of problems. And so we've kind of already talked about that, you know, we know that the nth root of a is equal to a to the 1 over n power. Okay, but similar to that, we can kind of derive that, well, what if I have n to the a to, and that inside of that we have some m power. Okay, well, really what ends up happening is we can just call this to the a to the m divided by n power. Okay, so we kind of have, again, have like a fitting formula we can go off of. But this makes sense because if it's just a, that's a to the first power, and so that first power kind of gets shifted up here, and it's this power divided by this one here, okay, as an exponent. Okay, and then we're going to go ahead and see how we can go try to do as much of this without a calculator, though we have that calculator as like a backup. Okay, so I have 16 to the 3/2 power. Okay, so that means this is going to be equivalent to the square root of 16 to the 3rd power. Okay, so 16 to the 3rd power, well, that's 16 times 16 times 16. Okay, well, we can evaluate that part here. So essentially when it says without the use of a calculator, what that means is I just see these steps that I'm showing here. Okay, this is the work I want you to be showing, is these steps, intermediate steps, just so we know how to use exponents is really the gist of what this this section's all about. Okay, and so we have the square root of 4096, okay, and so then we can go ahead and take the square root of 4096, which is 64. I'm taking it to an even root, so I should get plus or minus 4096. Nope, not 4096. 64. Okay. So then when I look at a problem like 4, I have a negative exponent. So we're going to have to recall some things about negative exponents. Okay, so if we have a negative exponent, you need to kind of remember that if I have a to the negative n power, that's going to be the same as 1 over a to that nth power. Okay, and so we have to just kind of remember that it's got this reciprocal nature, is that if it's above the fraction, okay, or so like this is over a sneaky 1, right? It's over like a hidden 1. Okay, and so it would just kind of put it at the bottom of a fraction. Similarly, if I had 1 over a to the negative n here, let's say it was on the bottom of the fraction, it now just becomes part of the top of the fraction. So we have, again, this reciprocal nature. Okay, so I'm looking at this one here, and I want to simplify this to the best of I can. Let's get rid of the negative aspect of it. That is probably just going to be confusing to each and all of you. Okay, so we can just put it at the bottom of a fraction, and then change that exponent to a positive. Okay, and so now, again, I just want to break this up into pieces. It's not that you can't use the calculator at all. It's just I want to break it up into parts. So what we can do here is we can go ahead and say 1 over, I'm taking the 5th root of this. Okay, so I'm going to take the 5th root of 32 to the 3rd power. Okay, and so then I'm going to finish my work up over here. Okay, so now I just got to figure out what 32 to the 3rd power is. So 32 to the 3rd power is a large number, 32,768. I'm taking the 5th root of 32,768. Okay, and then I want to take that to the 5th root. Okay, and so we need to understand that, you know, this 5th root can be difficult to put into the calculator. So we can just go ahead and call this 32,768 to the 1/5 power. Okay, and then that to the 1/5 power. I can just take my previous answer and take it to the 1/5 power and just get 8. So this final answer is just simply 1/8. Okay, and let's go ahead and double check that with the calculator. I mean, there's nothing wrong with using the technology that we have available to us. -3/5. Okay, so when I take it to the -3/5, okay, we get 0.125, but we can go to math and fraction and simplify that, and we see that it does end up being 1/8. Okay, why don't you all, again, try C and D just to the best. I just want you trying to show your steps through your work so we can just understand how these radical symbols and these exponents manipulate the problems. Okay, so we're doing C now, and I'm assuming that you've tried this already. We want to go ahead, well, we want to get rid of that negative aspect of it, so we want to go ahead and make it to the 1/9 to the 1/2 power. And then luckily, we really don't have to do a whole lot of work because 9 to the 1/2 power can be pretty easily done here because there's no larger exponent on the top, like we have a 3 and a 3 here. Okay, so we can just figure out what 9 to the 1/2 power is, and it's 3. We took that to an even root, so that means we're going to get two answers. We're going to get plus or minus 1/3. Okay, we can go ahead and check this if we wanted to. Okay, we can take 9 to the -1/2 power. We get 0.3, and then understand that when we simplify that fraction, it's a third. Okay, you're not going to be tested over how these problems, to be able to do these problems without a calculator. You're going to have it, but there are going to be problems where you're going to have to show your steps because it's going to involve variables. So that's kind of the point we have here. Okay, so D, we're kind of doing the same thing. There is no negative exponents, so we don't have to worry about getting that on the right side of a fraction or anything like that. But we can kind of just go ahead and do some work here and say that this is going to be the same as the 5th root of 8 to the 3rd. Okay, and 8 to the 3rd, we can go ahead and evaluate that 8 to the 3rd, which is 512. So now we have the 5th root of 512. And then we know that the 5th root is the same as the 1/5 power. So 512 to the 1/5 power here is, okay, it looks like we just get some sort of decimal, which is fine. Just making sure I have this all correctly done. And I do not. No, I do. No, I have it backwards. So let's go ahead and see the mistake I did. Is I'm actually taking the 3rd root of 8 to the 5th power is really what I did. So this is all incorrect. Hopefully you all caught that. So this is going to be the 3rd root of 8 to the 5th power. Okay, and that would be a pretty common mistake for anybody to make. So I guess in some aspect that's a good thing. I would like to lie to you and say that I did that intentionally, but I'm not sure that would be the truth. Okay, so let's go ahead and do it the correct way. I'm taking the 3rd root of 8 to the 5th power. So I would need to take 8 to the 5th power first to get 32,768. Again, okay. So we get the 3rd root of 32,768. And then taking the 3rd root of that is the same as taking this number to the 1/3 power. And here I would just get 32. Okay, I'm taking it to an odd root. Okay, so I'm only going to have one answer. Okay, now we can again check this and our answer and see that we did get 32, so that's fantastic. Okay. Okay, so now what do we want to do is when we do have a calculator, we want to understand that we need to manipulate the problems from radical form to exponential form. Okay, so anything like this, radical form, okay, if I have something in radical form, that means it's under a root. Okay, this is what I would consider radical form. Anything that has this root button or root symbol, okay, as opposed to exponential form. Okay, that would be like a raised to the m divided by n power. Okay, and this is the form here. this is our form that we want to use when we're utilizing a calculator. It's just the easiest if I'm going to level with you. Okay, so you need to have your answer, or you need to take whatever work you have and have it in exponential form when you're using the calculator. So like 5. If I look at 5, it's already in exponential form. So there's really nothing I need to do besides throw it in the calculator. Okay, so I can just go ahead and go 12, and I'm going to take it to the 3/8 power. And I get a decimal. We can always check to see if it comes out to if it simplifies into a fraction, and it doesn't. And we can just round to some value. Let's round to the hundredths. So 539, that 9 would round that hundredth spot up to 4. So this is approximately 2.54. Okay. So what about 6? So when I'm looking at 6, I'm taking the 4th root of this. So the 4th root is the same as the 1/4 power. So here I'm taking 16 to the 1/4 power, and then I'm raising that to the 5th power. Okay, so right now all I'm doing is I'm working towards getting my answer into exponential form. Okay, because 1/4 root is the same as 1/4 power. Okay, 4th root, same as 1/4 power. Well, here, exponential properties is I need to multiply here. Okay, if I have a power raised to a power, I would need to multiply here. It ends up being 5/4. Let's say you do not know how to do that. The calculator can multiply fractions for you. So we would go 5 times 1/4. And then you can hit math fraction, which we've done before in the past, to tell you that it's 5/4. Okay, lastly, all we have to do is throw this into the calculator. So we're going to go 16 to the 5/4 power to get 32. This is 32 on the dot. But we're taking it to, again, an even root. We're taking it to an even root, or we're evenly rooting, okay? That indicates to me that I'm going to have plus or minus. Okay, and actually that reminds me, actually, as we look here, I'm taking this to an even root. I'm going to get plus or minus technically within my answer. Okay, so look for the even roots. If you have an even root, that means you're going to have 2 answers. Okay, so let's look at E. Or actually, pause the video and try E and F on your own, and then check it with me. Okay, so as I look at E, this one is already in exponential form, so I just have to put it into the calculator. Okay, so I'm going to take 64, I'm going to raise it to the negative 2/3 power. All right, and I get 0.625. This is a terminating decimal, so I do know that this is going to simplify into a fraction, which is just 1/16. So I can get 1/16. If you gave me that decimal, I would think it's okay. I'm rooting odd with an odd number, so this is just the only answer. Okay, F. I'm taking the cube root of negative 30, and then I'm trying to square that. So that's the same as taking negative 30, and I'm taking that to the 1/3 power. And then I'm taking that whole thing, and I'm squaring it. Okay, so I'm taking a power to a power, so I would multiply these. So I would get negative 30 to the 2/3 power. Now it's in exponential form. I can just type this into the calculator. To the 2/3 power. Okay, it gives me some wonky number, which does not simplify into a fraction, so we can round that to the nearest hundredth. So this is approximately 9.65. Okay, so that's mostly just how these radical and rational exponents relate to each other, and how they have some, and how we can manipulate them. Okay, let's solve problems that have nth roots. So there's a couple different ways to look at this. Okay, we can go ahead and say that, nth roots undo that n power. So if nth roots undo n power. Okay, so fifth power, fifth root, undoes fifth power. Okay, this is just like an example. Okay, so when I'm looking at 7, I see 4 times x to the fifth power. 4 times x to the fifth power. Well, if I could get that x to the fifth power, that would be great. And we can do that pretty easily just by dividing by 4. So now I get x to the fifth power is equal to 128 divided by 4 is just 32. Okay, the fifth root, so the fifth root, which would be the fifth root of x to the fifth. These are the inverse operations of each other. So fifth root and 5 power, so the fifth power and fifth root undo each other. Well, we know that fifth root is the same as 1/5 power. We learned that in the previous pages. This is the same as the 1/5 power, which is equal to 32 to the 1/5 power. Okay, so what does this mean? Well, what would I do here with power to powers? I would multiply. Well, if you don't know that 5 times 1/5 is 1, I could show you with the calculator that it is 1. So here I just get x to the first power, which is just x. This is why they're inverse operations, is because those cancel out to an exponent of 1. Just give me x. Okay. Then we could take 32 to the 1/5 power. So 32 to the 1/5 power. And I get 2. So this is just equal to just 2 because I'm taking to an odd root. Odd root results in just one answer. Okay, so now I'm looking at 8. So I have x minus 3. That quantity is to the 4th power. So since that whole quantity is to the 4th power, I can go ahead and take it to the 4th root. So I'm going to go ahead and take this to the 4th root. Okay, 4th root is the same as 1/4 power. Okay, and that's the same as the 1/4 power. Okay, so we're going to get 21 to the 1/4 power also. Okay, and so as I look at this, I know just by showing previously that these are inverses of each other. They're going to undo each other. So they go away completely. So now I'm just left with x minus 3 is equal to, I got to take 21 to the 1/4 power. Okay, and it doesn't look like that's going to simplify. So we're going to get to round here. So we'll go to the nearest hundred. So 2.14. Specifically, plus or minus 2.14. Okay, it's plus or minus because I'm taking it to an even root. The root I'm taking is even, so I'm going to get plus or minus. Lastly, I would just have to add 3 to each side to get x is equal to 3 plus or minus 2.14. Okay, and so, I mean, I would accept this as your final answer, but you could also give me the exact 2 answers, 3 plus 2.14, which is 5.14. And then also x is equal to 3 minus 2.14, which is 0.86. Approximately, right? And it's approximated because we rounded. Okay, so that is 7 and 8. Why don't you guys pause the video and try G and H on your own and see how you do. Okay, we need to get the variable here by itself, so we can divide by 8. Okay, so then I'm getting x to the 3rd power is equal to 8. 64 divided by 8 is 8. Then I can cube root each side because cube rooting is going to undo cubing. Okay, and this is the same as to the 1/3 power. Okay, and then that leaves me with just x is equal to 2 as well. Okay, and it's just 2 because I'm taking it to an odd root, so it's not plus or minus. Okay, this one here, there's no extra work, but that whole thing is being cubed, so we can go ahead and cube root this whole thing. All right, and so I'm going to get x minus 2 cubed, and that whole thing to the 1/3 power. 1/3 power is the same as cubing, or cube rooting. Okay, these undo each other, so I'm left with x minus 2 is equal to, well, negative 14 to the 1/3 power. Negative 14 to the 1/3 power. That's going to be equal to negative 2.41. It doesn't simplify, so we can go ahead and get negative 2.41. Okay, and it's not plus or minus again because I'm taking it to an odd root. Lastly, I can just add 2 to each side to get x is equal to negative 0.41. Okay, just one answer. Okay. And again, a lot of times this higher level math, they just use technology to model or give you an equation that you can plug in your values. So that's where we're going to go with this. Okay. A hospital purchases an ultrasound machine for $50,000. The hospital expects the useful life of the machine to be about 10 years. Okay. At which time the value will have depreciated to $8,000. So 10 years after they purchased it, they're expecting it to be about $8,000. The hospital uses the declining balance method for depreciation. Okay, so the annual depreciation rate R is given by this formula. Okay, in the formula, N is the useful life of the item in years. S is the salvage value. C is the original cost. What's the depreciation rate? Okay, so we can see somebody's model of this ended up using a fractional exponent. So that means that this is just a great application of it. It's really quite simple. So we have this problem here. And all we have is variables, right? So we just need to know what S is. Well, S is the salvage value. Well, how much did they salvage it for? Looks like about $8,000. Over C, which is the original cost, which is about $50,000. And then that's being raised to the 1 divided by N, which is the useful life in years, which was 10 years. Okay, and then really this is just an equation that all we have to do is simplify. Okay, so let's go ahead and take this value here. We're going to go 8,000 divided by 50,000 to get 0.16 minus 0.16 to the 1/10 power. Okay. And then we need to know that, hey, I can't subtract these until I evaluate this exponent based on our basic order of operations. So we need to go ahead and do that. 0.16 to the 1/10 power. This is not going to simplify into something nice and neat. So we're just going to round and say it's approximately 0.83. And then we take 1 minus 0.83. 1 minus 0.83, which is 0.17. So my rate is 0.17. Okay, what does that mean? That means the rate, it depreciates at about 17% each year. So each year, the value is losing 17% of what it was at.